Okay, let's go to page 75 and section 6.3, finding the roots of polynomial. Now, sometimes when they give you a polynomial and they don't give you any clue, okay, and so you got to know how to find the roots and so forth. But the first one is first thing let's go and do is how to do with the how to use these. Okay, so let's go to example 6-3. On page 76. So it says p of x is a polynomial with a real coefficient. Okay. So when p of x is divided by x minus 1, this will give you a remainder of 3. When p of x is divided by x minus 2, the remainder is 5. Find the remainder. Okay, so you have p of x is divided by x squared minus 3x plus 2. So when you divide, and what would be the remainder? Okay. Okay. So again, this problem again you have to use this right over here. Okay. So if you write it out, so p of x would be equal to x squared minus 3x plus 2 times q of x. Okay. So again, when you divide, okay, you're going to get quotient plus the remainder over the divisor. So you cross multiply, you multiply out, so you're going to end up with these. Okay. Again, that's what we're talking about. Right? So this equation, this over here is this over here. You got quotient plus the remainder over the divisor. So that is this. So if you were to multiply by the divisor, your original function, your polynomial will equal to the divisor multiplied by quotient plus the remainder. Okay, so that's what we're going to use. So this will equal to plus r of x. So using that. Okay, so we will cross multiply already. So we're going to have that. Okay, so next thing is p of x will equal to. So we're going to factor these. Okay, so you're going to get x minus 1, x minus 2, q of x plus, now the remainder will always 1 degree less than that, but we don't know what is it, so it's going to be the first part, so we're just going to call it ax plus b. Okay, now if it's the second degree, it will have an ax squared plus bx plus c, and so forth and so forth. Okay, okay, so we're looking for remainder, so it means we're looking for a and a b. Okay, so what we're going to do is we're going to use this clue right over here. Okay, so again, remember from your remainder theorem, the remainder and the substitution are interchangeable. Okay, and so what we're going to do is we're going to let x equal to 1. We want to choose a value so that this will equal to 0, so this will be cancelled out. Okay, so we're going to use p of 1. Okay, so when x equal to 1, this will equal to 0. Right? Okay, and so it doesn't matter what this is, right? Okay, let's just put, okay, when p of 1, this will equal to 0, and okay, so plus a times 1 plus b. Okay, but we know what p of 1 is. Okay, when you divide, see, this is p of 1. Okay, so again, the remainder and substitution are interchangeable. So when you substitute p of 1 in here, okay, see, when you divide, when you insert division, this is x, means you have to divide by 1, right? So this is this. So p of 1 is equal to 3. Again, remember the remainder theorem, the substitution and the remainder are interchangeable. So p of 1 is 3. Okay, so you're going to get a plus b. Okay, so p of 1 equal to 3. So you're going to get that. Now we're going to use a second clue. We're going to use a p of 2. Okay, I'm going to call this equation 1. So now we're going to do p of 2. So p of 2, when x equal to 2, this will also equal to 0, right? So this 0 times anything will equal to 0. Okay, so now x equal to 2, so you're going to get a times 2 plus b. Okay, so p of 2 from here, p of 2 is equal to 5. Okay, So 5 is equal to 2a plus b. Okay, so this is equation 2. So what we're going to do is we're going to use equation 2 minus equation 1. Okay, so we got 2a plus b, we got a plus b, right? This is equal to 5, this is equal to 3. Okay, so we're going to subtract. So this way a equal to 2. So once you find a equal to 2, from here you can see that b equal to 1. Okay, so once you find a and b, then that's your r, right? Remember, that's your r. So your r of x is equal to 2x plus 1, and that's it. Okay, so that's how you use the remainder theorem. Okay, so this is a very important equation to know. So this is very important equation. You're going to use this a lot to find whenever you deal with remainder. Most likely you're going to use in this. You probably want to write this out and then change into this. So these are super important. Okay. The next one is the root theorem on page 77. So what we just covered is a remainder theorem. So now we're going to cover the rational root theorem. Okay, so the best way to kind of explain that is just using an example. So let's go to example 6-4. So you got x to the 3 minus 6x squared plus 11x minus 6. Okay, and to find all the roots. Okay, so the root theorem says that first you find the factor of the coefficient. So this is 1. So coefficient would be the factor would be plus or minus 1. This one, the factor of negative 6 would be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So the possible candidate of the root of the rational roots would be the ratio of this over this. Okay, so this over this would be plus or minus 1, this over that would be plus or minus 2, this over that would be plus or minus 3, this over this would be plus or minus 6. Okay? And so the way to do it is you're going to use substitution to see if this is equal to 0. So you substitute 1 into here and see what you get. Okay? If equal to 0, then that's the answer. Okay? So for example, if you put 1 in here, so you're going to get 1 to the 3 minus 6 times 1 squared plus 11 times 1 minus 6. Okay? And so this would be equal to 1 minus 6 plus 11 minus 6. And so this is equal to 0. So the one that you put in equal to 0, remember, that means the remainder equal to 0. Right? Remember, substitution and remainder are interchangeable. So substitution, the remainder equal to 0. That means when you divide by x minus 1, you get remainder of 0. It means this is a factor of that. Okay? Or this is a root. Okay? So 1 is one of your answer. Okay? And you can check all of them. Okay? But there's a fast way to do this. Instead of substitute every single one, there are 8 of them you have to try. Okay? So instead of doing that, what you want to do is you can use synthetic division. It's a little bit quicker. So when you're doing the synthetic division, you're going to get 1, negative 6, 11, negative 6. Okay? So when you try 1, so instead of substitution, you also, depends on which one. If you have the things that are super long, okay, or if it's really long, you probably want to use synthetic division. If it's short and very high power, let's say if you have something like x to the 100 power minus 1, right? In this case, you want to use substitution technique, right? But if it's low power and long, you want to use synthetic division. So it depends on the situation, okay? But remember, synthetic division and substitution and remainder, they are all interchangeable, okay? Okay, so if you try 1, you drop, multiply, you add, multiply, you add, multiply, you add. So if it come out remainder equal to 0, it means this is your answer. Okay, so that's one of your answer. Then from there, once you get to quadratic, don't waste your time try to substitute every single one of them. Okay, it's quicker if you just go and just write this equation and just do the factoring. Okay, so there will be x minus 2, x minus 3. So your next two answers would be 2 and a 3. So your answer would be 1, 2, and 3. Okay? And this is a cube, so therefore you're going to get 3 answers, right? Okay? Okay, so again, there are many ways you can do this. Okay, there are long way, there are short way. So once you get one of the answer, once you get to the second degree, it's easy if you use factoring or quadratic formula. Okay? Okay, the longer way is if you try every single one and substitute every one of these to find out which one works, which one does not. Okay? Okay, let's go to the next one. Let's go to example 6-5. Okay, finding all the roots of 2x to the 3 minus 5x to the 2 plus 4x minus 1. Okay. Okay. In order to find roots, you actually have to set it equal to 0. Okay. Roots are for equation, right? Okay. So this is kind of not really technically correct. Find all the roots. You have to have, because it's an expression, you have to have equal to 0 in order to have a roots. So this one's kind of a little bit bad. Okay, again, you have to have equal to 0, have an equation in order to solve for roots. Okay, so again, you're going to have a plus or minus 1, plus or minus 2, right? The factor of this. This would be plus or minus 1. So the ratio of this over this would be plus or minus 1. This over this would be plus or minus 1 over 2. Okay, so you have 4 choices you want to try. Okay, so you want to keep track of what you try. The first one is you substitute x equal to 0. Right? Remember, since that deviation, remainder, and substitution are interchangeable. So if you substitute x equal to 0, all this will be gone, so you're going to get negative 1. Okay? Again, you want to play, like a high-low game. Okay? So you want to see, your goal is try to get into 0. Okay? Okay, so let's go and try this. So 3 to 1 power negative 1. Okay, so we're going to try, normally I like to try 1 first because it's easier to evaluate. So you try 1, so you drop the number, multiply, you add, multiply, you add, multiply, you add. Oh, we got lucky. Okay, you got correct on the. So when you try 1, you get 0. So that's your root already. Okay. Now, you don't want to try other numbers. Okay. The reason you don't want to try any numbers because it's better to just go and use your quadratic formula or use your factoring to solve. So this is your 2x squared minus 3x plus 1 equal to 0. And let's see if we can factor. So it would be negative 3, 2. Okay, so it would be negative 1, negative 2. So it works. Okay. So again, once you get to quadratic, it's easy if you just use factoring or use quadratic formula. So this would be your inside, right? Use your factoring. So it would be minus 1 and minus 1. Okay, this is outside. So again, inside, negative 1 times 2 give you negative 2, and this give you negative 1. So from here, you're going to get x equal to 1 and x equal to 1 over 2. So notice 1 is a double root. You got 1 here, you got 1 here. So you're going to get 1 as a double root, and then you get 1/2. So you got 3 answers, right? 1, 1, and half for 3 answers. Okay? Okay, another option is you substitute 1 into here, see if you get 0. Then you substitute negative 1 to see if you get 0. You substitute 1/2 to see if you get 0. Substitute negative 1/2 to see if you get 0. Okay? But the problem with this one is you don't really see the double root. Okay? When you do that. Okay? So if something works, you might want to try it again to see if it's a double root. Okay. Okay, so that takes care of that. Okay, next one is Descartes' rule of sign. So on page 79. So Descartes' rule of sign tells you that it kind of gives indication of how many positive roots, so it gives you additional clue. Okay, so for example, you have f of x equal to 3x5 plus 2x to the 4 minus 3x2 plus 2x minus 1. So what you do is look for the change of sign. So this is positive. So from positive to positive, it does not change. So from positive to negative, it changes. Okay? And from negative to positive, it changes again. So from positive to negative, it changes again. Okay? So this tells you there are 3 positive. Whenever it changes, it means, so you got 1, 2, 3, it changed 3 times. So when you look at your sign, so you have positive roots, negative roots, and imaginary. So this gives you a maximum of 3 positive roots. Okay? Then you do the f of negative x. So whenever your r power, it will change, right? Because you're going to get negative x to the 5 power will give you negative. So this becomes negative 3x to the 5 power. The even power does not change. So the positive remain positive. This one, again, if it's even, it will stay the same. Okay? The r exponent will change. Okay, so again, you look, so this one change, yes. This one change, yes. No, no. So you're going to get a maximum of 2 negative answers. You're going to get 3 max. This is your max, the max. Okay, so the first one you try is your max. So this kind of gives you a clue of how many positive answers, how many negative answers you're going to get. In this case, it will be 0. Then after that, now there are more possibility though. So this is your maximum. So that means you can have 1, 2, and 2. Okay. Now imaginary answer will always be conjugate. Okay. Therefore, it will be always be multiple of 2. Okay. So you have to go down by 2. So another possible solution to this equation is 1 positive answer, 2 negative answers, and 2 imaginary answers. Or you can have 1, 0, 4. Okay. And you can have 3, 0, 2. Okay. So So again, this has to go down by 2s. This can go down by 2. So these are all the possible combinations of answers to these. So this just give you additional clue. In addition to this, so you know, like give you an idea of what to try. Okay. So if let's say if you have no negative answers, then you should not try negative answers over here. Okay. If there's no positive answers, then you should not try positive over here. Okay. So that's what the decausal rule tells you. Okay. Also, another clue you can get from this is that if you do the divisions, like if you have 1, negative 1, 2, 6, right? When you divide by 3, okay, so you got 1 and then 3, you add. So this is from page 79. So again, all these give you a clue of what to try. Okay. Okay, so if you notice, if all these are positive, that means this is the maximum. This is your upper limit. Means you should not try anything higher than that. Okay, if this is all positive. So it means you don't waste your time try 6 or 4 or 5 or whatever. So it tells you that this is the upper limit. So there's no answer higher than this number when all these are positive. Now, if all these are negative, that means you do not try any number less than that. Okay, when all these are negative, means this is the lower limit. So again, they kind of narrow it down what number to try. Because sometimes you're going to have, when you try the combination, like sometimes there's a very long list. Okay? So by doing that, it will kind of narrow down your list. Okay? So again, if all these are positive, then means there's no answer beyond this, above this. When all these are negative, that means there's no answer below that number. Okay? Okay, let's go and do a couple more examples. Okay, let's go to page 80 and let's do example 6-7. Okay, so you're looking for all the roots. Okay, so you have x to the 4 minus 10x to the 3 plus 35x to 2 minus 50x plus 24 equal to 0. Well, first of all, right away, you know that there will be 4 answers. Okay, there will be 4 answers. So the factor of this would be plus or minus 1. The factor of this would be plus or minus 1, plus or minus 2, plus or minus 3. And I'm going to do on this side. So 1 and 24, 2 and 12, 3 and 8, and 4 and 6. And when you have this over that, okay, it's 1. So this would be your list. So that means there are 16 possible numbers you can try. Okay? But first, let's go ahead and look at some clues. Okay? So notice that this change, this change, this change, this change. Okay? So that means there are 4 positive roots. From here, it tells you that there are 4 positive. So again, if you keep track of your signs, your positive, negative, I, right? So 4 is your max. So if there are 4 positive answers, that means there's no negative answers. Okay? So again, this is what it helps you. So it means don't try any negative. It's not going to work. Okay? Because there's no negative over here. 0 is your max number of negative answers. Okay? But there's other possibility. This does not give you just this nice 4. Because you can have 2, 0, 2. Again, the positive and negative can only go down, cannot go up. The I can go up. Okay? So these are your choices. Okay? So you can have 4 positive answers, or you can have 2 positive answers and 2 imaginary, or you can all 4 imaginary. Okay? But at least we know that there's no negative answer, so do not try any negative numbers. Okay, then you also need to keep track. So again, if you let x equal to 0, you're going to get 24. Okay? So that's you always start with 0. That way kind of give you the starting point. That way you can know if you have to go up or down. Okay, so now let's go and do the synthetic deviation. Okay? And I always like to start with 1 because 1 is kind of easy to do, right? So I'm going to start with 1 because 1 is on the list, right? Okay, so I try 1. So drop the number, multiply, add, multiply, add, multiply, add, multiply, add. Okay, we got lucky. Okay, so 1 you get 0. So this is one of your answer already. Okay, but we still this is still cubed, so it's going to be kind of hard to do. Okay, so what you want to do is you want to try 1 again, just in case if it's a double root. Okay, so you want to try 1 again to see if it's a double root. Okay, so I'm going to try 1 again just to make sure that it's not a double root. Because if you don't, then if it's a double root and you don't check, you're going to waste your time doing all that without finding the answer again. Okay, so you drop, multiply, you add, multiply, you add, double check. Okay, add. Okay. Okay, so when you try 1 again, you're going to get 14. Okay? And now you can start with a new, this is a new problem. So if you try 0, you're going to get negative 4. Okay? If you try 0, you're going to get negative 4. This will really narrow down your list. So don't start all over the, oh wait, I messed up. This is a 24. So this will be a negative 6. Okay. Okay, when you try 1 again, it does not work because, so you know that this is not a double root. Okay, so let's go and try the next number 2. Okay, now why we don't try the negative 1? Because we know that there's no negative answer. Okay, so I'm going to try 2 next. Okay. So you drop, multiply, you add, multiply, you add, multiply, you add. Okay, so that's not bad. So when we try 2, we get 0. Okay, so that's your second answer. Now once you get to this part, once you get to quadratic equation, don't try don't do that. Don't try to guess again, because you can do factoring or quadratic formula to find the last 2 answers. Okay, so you can factor to be negative 3 and negative 4. Okay, so actually those are, okay, so you're going to get x minus 3, x minus 4. Okay, so your answer would be 3 and 4. So from here we get 1 and 2. Okay, so that's how you get the answers. So again, as soon as you get quadratic, okay, don't try to guess again, because guessing, you have this list. Guessing, it takes too much time. Okay. So once you get quadratic, you can know for sure for the last 2 roots. Okay. Okay, let's go and do the next example. Okay, so page 81, example 6-8. Okay, so it says I'm trying to find the roots of f of x is equal to 2x to the 4 minus 15x to the 3 plus 15x squared plus 20x minus 12. Okay, it says I start with x equal to 1 after I finding f of 1 equal to 10. Okay, so you can right away you can start with 0, right? So when you substitute x equal to 0, you're going to get negative 12. And over here it tells you that, okay, you know, he said I tried with x equal to 1 and he get 10. Okay, so what should he try next? Okay, well well, a couple of things. Okay, so first if you look at the sign, so this is yes, right? It changed, right, from positive to negative, from negative to positive, and from positive to positive doesn't change. From positive to negative, yes. So it tells you that when you do the signs, right? So there would be 3 positive answers. Okay, that means again there are total 4 answers. That means you're going to get 1 and 0 because the conjugate, the imaginary always conjugate. So right away, without doing the f of negative x, you know that it's going to be 3, 1, 0. Okay, and therefore the next option would be 1, 1, 2. So there are only 2 options like this. So this kind of gives you some clue, but this one doesn't really help us because we don't know which one is this, right? Okay, now over here, you know that there's going to be one answer between 0 and 1 because remember, see, when you get 0, if you use 0, you get negative 12. When you go 1, you're going to get 10. Right? So we know that's going to be one answer in between here. Okay, and again, if you try, okay, the list. If I didn't make the list, but if you try the list, the number you can try is 1/2. Okay. So if you try 1/2, right, looks like somewhere in between, right? So again, when you keep track of the number you try, it tells you where the answer can be. Okay, so you drop the number, multiply, you add, multiply, you add, multiply, you add, multiply, you add. So yes, when you try 1/2, you get 0. Okay. Okay. So it says, what should I try next? Well, the answer would be 1/2 because there's one. Because of this, there's one answer between here, right? Because there's a 0 in between, so the answer should be somewhere in between. So the next number should try is 1/2. And if you try, yes, it works. Okay, so that's what all the things we cover is give you the clue of how to narrow down your choices, how to narrow down what number to try.